The skeleton was a metre tall with a brain a third the size of ours. Either it was a modern human with a rare disease, or it was a kind of human no one had ever named. The bones came out of a cave called Liang Bua on the Indonesian island of Flores, catalogued as LB1, a fully grown adult who stood only about 3.5 feet tall. Lifted from the wet brown earth piece by pieces, a whole skull far too small for an adult, then a thigh, an arm, a nearly complete body. When the discovery was announced in 2004, the research team argued that LB1 was not a modern human at all, but a member of a previously unknown human species. They named it Homo Floresiensis. The press called it the Hobbit. And almost immediately, other scientists pushed back, because the alternative was far less exotic. What if LB1 was simply a modern human, deformed by illness? The claim was extraordinary, and extraordinary claims draw hard scrutiny. A separate kind of human surviving on an island would mean the human family was bushier and stranger than the textbooks showed, with more than one sort of human sharing the planet far later than assumed. Some researchers found that thrilling. Others found it too much to accept from a single small skeleton, and went looking for a more ordinary explanation. That question sounds small. It is not. Everything about the story depends on it. If LB1 was one sick individual, there is no lost species, no separate branch of humanity surviving on a remote island. If LB1 was healthy for what she was, then a different kind of human had been living on Flores, apart from us, for a very long time. So the science turned to the bones themselves, and to a single hard problem: can you tell a disease from a species? The first target was the brain. A brain of about 400 cubic centimeters is small even for a human ancestor that lived millions of years earlier. Critics proposed microcephaly, a condition that produces an abnormally small head. It was a reasonable place to start, but when researchers built a virtual cast of the inside of the skull and compared its shape to microcephalic brains, the match was poor. The proportions did not line up. Microcephaly could not comfortably explain LB1. Other conditions were offered in turn: Laron syndrome, a form of thyroid deficiency, and later Down syndrome. Each proposal had to explain not just the small size, but the specific combination of features in the skeleton. And that combination kept causing problems, because some of the features were not the kind a disease usually creates. The Down syndrome proposal, published about a decade after the discovery, pointed to asymmetries in the skull and to revised height estimates. Other researchers disagreed sharply, finding the measurements and the diagnosis unconvincing. The exchange showed how alive the argument still was, but it kept running into the same wall: parts of the skeleton that take shape too early in life for a childhood condition to explain. The clearest example came from the wrist. LB1's wrist bones are shaped like those of much older hominins and of living apes, not like the wrist bones of any modern human, healthy or ill. Crucially, these bones take their basic form very early in life, long before most illnesses would reshape a body. A modern human with a disease would still have a modern human's wrist. LB1 did not. The foot told a similar story, unusually long, with a structure that would have changed how she walked. These were not the marks of a single sickness. They looked like the anatomy of a different kind of human. Then came the detail that a disease argument struggles hardest to survive. LB1 was not alone. Excavations at Liang Bua recovered parts of at least 9 individuals: jaws, limb bones, teeth, all small, spread through the deposits over thousands of years. One person can be unusual. A whole population, appearing again and again in the same cave across deep time, is much harder to dismiss as a string of coincidental illnesses. For most researchers, that shifted the balance. A minority still argues for pathology, and the debate has not been silenced entirely. But the weight of the evidence moved toward a genuine, distinct population of small-bodied humans on Flores. The obvious next question was where they had come from. There was a deeper puzzle inside the skull, one that unsettled a long-held assumption. Stone tools had been found in the same layers as the small humans, simple flakes and cutting edges, the work of hands that knew what they were doing. Yet the brain that seems to have made them was tiny, far smaller than the brains usually tied to that kind of tool-making. It forced an uncomfortable question. How much brain does it take to plan, survive, and shape stone? On Flores, the answer appeared to be less than anyone had assumed. Brain size had long been treated as a rough measure of capability. LB1 suggested that measure was too simple. The world these humans lived in was its own kind of strange. Cut off on an island, evolution had reshaped the local animals into forms found nowhere else. A stocky elephant relative called Stegodon had shrunk to a fraction of its mainland size. Overhead cruised a stork taller than the humans below it. Along the ground moved giant rats and monitor lizards large enough to be dangerous. Stegodon remains, many from young animals, turn up in the same deposits as the stone tools, which has led some researchers to suggest the small humans hunted or scavenged them. That link is plausible but not proven. Bones sharing a layer do not by themselves show a hunt. What the deposits do show is a small human population holding its own for a very long time in a landscape of oversized predators and dwarfed prey. Here the story reaches back much further than the cave. Islands do strange things to the animals stranded on them. Large species often shrink over generations because a smaller body needs less food, and food on an island runs out fast. If a dwarf elephant could evolve on Flores, the argument went, perhaps a human ancestor had too. The leading idea was that Homo floresiensis descended from Homo erectus, an early human known from the wider region, which over many generations on the island evolved a much smaller body. It is a clean explanation. But it is not the only one, and it is not settled. Some of LB1's features are more primitive than Homo erectus, closer to older, smaller hominins. That raised a second possibility, that the ancestors of the Flores humans were already small when they arrived, an earlier branch of the human family that had left Africa and reached Southeast Asia long before anyone expected. The ground under the debate shifted again in 2016 and twice over. First, a site called Matamenge in a river basin elsewhere on Flores produced fossils of small-bodied hominins dated to around 700,000 years ago, hundreds of thousands of years before LB1. Their teeth and jaw were tiny, in some ways even smaller than the Liang Bua humans. Small body size on Flores was not a recent accident. It was ancient, and it ran deep. More recent work at the same site pushed the picture further. A fragment of an adult arm bone from those old layers proved even smaller than the matching bone in LB1, hinting that the earliest Flores hominins may have been smaller still. Whatever process shrank these humans had, in some ways, already gone further 700,000 years ago than it had by the time of the Liang Bua skeletons. The second shift was about time, and it corrected the story's most famous claim. The original dates had placed LB1 at around 18,000 years ago, recent enough that these small humans would have shared the world with fully modern people well into the last ice age. But a careful study of the cave's layers showed the sediments around the skeleton had been misread. The remains were far older. The skeletal bones date to roughly 60 to 100,000 years ago, and the stone tools linked to these humans span from about 190,000 to 50,000 years ago. The Hobbit had not survived until nearly yesterday, in geological terms. The vivid image of tiny humans living beside modern people just 12,000 years ago quietly dissolved. What remained was still remarkable. For a very long stretch of time, a small-brained, small-bodied human population had lived on Flores and made stone tools. And the tool-making reaches back even further than the skeletons. Simple worked stone appears on the island from around 1 million years ago, far earlier than any known bones, which means some kind of tool-making human reached Flores astonishingly early. Set beside a modern adult, one of these humans would have reached only to about the chest. To move through that island world at barely 1 meter tall, with a brain a third the size of ours, gathering, making tools, avoiding the largest predators, is a survival story in itself, even without a single invented scene to dress it up. And that leads to the hardest unsolved problem of all, not what these humans were, but how they ever got there. Flores sits east of a sharp biological boundary that runs through Indonesia. To the west, animals crossed on land bridges when ice ages dropped the sea. To the east, deep water straits never closed, even at the lowest sea levels. Flores was always an island, and reaching it meant crossing open sea. The few land animals that made it there in deep time, the ancestors of the dwarf stegodon, some rodents, were the kind that could survive being swept across water during floods or storms. A large, land-bound primate is a far less likely passenger. Yet somehow, more than once, tool-making humans reached the island. They left no boats, no rafts, and no clear sign of how they crossed. Whether they drifted over by accident or reached it in some more deliberate way, the evidence does not yet say. The water is part of the mystery, not a solved chapter of it. The disappearance is uncertain too. The traces of these humans in Liang Bua fade out around 50,000 years ago. Modern humans were spreading through the region near that time, and a volcanic eruption is recorded in the cave's layers as well. Either could matter. Neither has been shown to be the cause. The honest answer is that the end of Homo floresiensis is not yet written from the evidence. The discovery also changed something larger than one island. When LB1 came out of the ground, the standard picture still leaned toward modern humans as the last hominins standing alone for a long stretch of the recent past. Flores helped complicate that. Alongside the Neanderthals of Europe and the Denisovans of Asia, the small humans showed that the recent human family had been crowded rather than empty. Several kinds of human in different corners of the world, overlapping in time. The tree was not a single trunk narrowing neatly to us. It was a spread of branches, a few of which reached close to the present, and most of which did not. What can be said is narrower and stronger for being careful. On one island, for a great span of time, there lived a human population unlike us in size and brain and hand. Not a diseased version of ourselves, not a failed attempt at being modern, but a separate outcome of the same deep human family tree. They were not a step on a ladder toward us. They were a branch that grew somewhere we were not and lasted far longer than a single strange skeleton first suggested. The bones can tell us that much with confidence. Where their ancestors came from, and how they ever crossed the water to a place they were never meant to reach, are questions the island is still keeping.